So I'm talking about the stacking conservation practices at Wellsville and for Vernal. So we will be hearing from Boyd via some video later on. So at Wellsville, we have a lot going on. We are stacking soil management practices of tillage versus no-till. We've got drought tolerant genetics versus conventional genetics. We've got soil additives of AquaDrive to see how that affects yield. We had cover crop this year in certain plots. We've got a hemp study, couple hemp studies through the middle of the field. And then we have our alfalfa established this year, doing similar genetic trials and with the irrigation technologies and different rates. You can definitely tell the 50% partials in the alfalfa. They're the much lighter streaks through the field. So we have 5 different technologies that we're looking at Wellsville. Our overhang has comets this year, but the main 5 are Lena, Mesa, Lisa, MDI, and then LIPA. And then our crops are alfalfa. This is its first year established. We had safflower last year as our alternative crop. This year it's been replaced with hemp, and we have our second year of corn in with with all the different stacking management practices. So instead of spending a whole lot of time, we're not out in the field, we're just going to kind of go into some results we've had from last year and this year. Last year, it was a obviously wetter year than this year. With the corn silage, we did not see any significant differences between crop genetics. Drought tolerant genetics did slightly better in the yield and irrigation productivity. For irrigation productivity, we're labeling that as the yield of the crop per applied water inch. So last year, corn averaged about 22 to 25 tons an acre. We only applied 13 inches of water in the 100% rate. So a lot of corn, not a lot of water applied, but it was a wetter year last year. For the soil additive, I mentioned it's AquaDrive. The point of AquaDrive is it's supposed to turn hydrophobic soils into hydrophilic. So the soil is supposed to be able to absorb water better and hold it in place. Last year, we did not see an increase in yield with the interaction of the genetics and soil additive. As you can kind of see, plots with the soil additive did slightly worse. In irrigation productivity, the AquaDrive did not make a difference. If anything, it was worse. We're hoping to see a different change this year. We applied it earlier, and the rate for it changed. Last year, the label rate was 3 pints an acre, and this year it changed to 2 quarts an acre. So perhaps that'll be a difference. For the irrigation technologies, that's where we started to see some differences in the yield, where LIPA, MESA, and Lena were all the same. Lisa did a little worse, and MDI was relatively the same as LIPA and Lisa, but still did not perform the highest. For irrigation technologies, they were all the same across the board. For our irrigation rates, that's where we started to see differences. 100% did the best in yielding, but the 50% was statistically not different from 100% or 75%. Whereas irrigation productivity, we saw the best productivity out of the 50% rate. Last year, the 50% partial was actually a 75% partial due to a few overwaterings. And the point of the 75% partial or the 50% partial that we are doing this year better is we're still putting on 50% of the water, so it's a reduction in half, but we're focusing the amount of water towards critical periods of time. So especially around tasseling and silking for corn. For safflower yield last year, this is a really messy, really busy graph, but the overall takeaway from it with the safflower is we saw overall good yields out of LIPA LIPA at the 50% partial, MDI at 100, MDI at 75%, MDI at 50% all performed about the same, and same with ELISA at 100. We didn't see major decreases in yield from the irrigation technology and rate interaction until we got to the side of Lena. This could also be due to the Lena side of the field in the safflower section seems to be slightly different soil, so that could have been a reason for the decrease in yield. So I mentioned it was an overly wet year last year, and this year's turning out to be a much drier year. 2019's weather data is on the left against the 30-year averages, and as we see, January through May was much wetter. That's a much wetter spring. As of this year, it was drier except for March, and we had a spike in June, but nothing considering compared to last year of rain. Temperatures have been about the same. For the alfalfa, it was planted last August, so there was no data from it last year, but we did get our first harvest on July 9th. And here's some of our results. There was no significant differences between the interactions of the genetics, the irrigation technology, or the rate. It was more, they were just based off individual factors. So the yield was affected by the technology in both irrigation productivity and yield, with LIPA and Lena coming out at the top of yield. And then in irrigation productivity, they were about the same again, with Lena leading the way, but LIPA not that much different. For the rate, we did see differences to 50% partial, definitely had a decrease in yield, and that was quite obvious in the aerial photo over the field. It's much lighter green. So we did see a lot better yield, but in productivity, the 50% did do pretty well, considering there was only about 5 3/4 inches of water applied this season. We're hoping to see different results with the second cutting. And for the genetics, their drought-tolerant variety we're using is Ladac 2, and we did see there was not as much yield or irrigation productivity with this line of genetics. Maybe we'll see a difference in cutting 2. We'll have to wait and see how it does with the aging of the stand as well. So into the vernal updates, you don't get to listen to me as much. You get to hear from Boyd some. And these are graciously slides given to me from him. So I'm talking on what he wanted to talk about. So the Vernal USU farm site, it is a clay loam with water holding capacity of about 2 inches per foot. There's 1.5% organic matter. The water table is at about 7 to 8 feet deep with the tile drainage. The irrigation source at Vernal is the Ashley Upper Canal, dependent on the Ashley Creek. There's plenty of spring flow, but it'll run short in the late summer and dry years. We could be seeing that this year. And the pressure varies from 30 to 100 psi depending on the number of irrigators who are asking for water at a certain time.
Technology here is called mid-elevation spray application, which we abbreviate MISA. So it's, and this is the most typical application that a person with a pivot or lateral would use today. The spray nozzles are down off of the top. They're on drop tubes, but they're up, somewhere to 4 to 6 feet high off the ground and spray quite far. And so we have this technology, and in each one of these spans, each span has a different technology, but each of these spans has 4 different irrigation treatments. One of them is 100% of the needs of the crop. The other one is designed for 75%, one for 50%, and one of them is what we call partial, which means we can turn it from 100 to we can turn it off, we can use 50, or we can use 100. The goal is to change the timing of when it gets watered but end up with 50% irrigation as a total over the season. I want to also just talk about this crop here. We have 3 crops that we're looking at in Vernal in 2020, and the crop we've got right here is teff. This is a grass, a very fine grass. It's an annual, a summer annual grass, and it's doing quite well, at least right this area here. It will be cut for hay. It's a fine stemmed grass, preferred by horse owners, and even used in dairies in some situations. So, and it's from Africa and considered to be a drought resistant type of grass. So that's the 3rd crop, or one of the crops that we're looking at here in Vernal. Okay.
The other 2 crops we're looking at Vernal are corn for silage, similar to Wellsville, and we will be planting alfalfa soon. But to break the cycle between the last alfalfa stand and this coming in one for our research, a 3-way grain mix was established, and I will be talking about those results. Is my volume okay, or do I need to turn it up?
Sounds good.
Okay, thanks.
This is the 2nd span of our lateral, and then this span we use what we call low elevation spray application. The heads are a little bit closer together. They're fairly close to the ground, about 18 to 24 inches off the ground. They spray not as far out, and it reduces the amount of water that's lost to evaporation. And again, we have 100%, 75%, 50%, and a partial irrigation in this span, in this technology, for all 3 crops. Okay, let's go over to the drip. This is the second. Okay. The 3rd span, the technology is called mobile drip irrigation. In this case, these are drip irrigation lines that are drugged by the lateral, and so they emit water, and the amount of water they emit is correlated to how long the drip tape is. So we've got again, we've got the 4 different rates here. These drip lines are every 25 or every 2.5 feet or 30 inches, and the emitters, you can zoom in on the emitters. They're about every 6 inches, right here on the drip tape. Again, we have 175, 50, and partial irrigation that we could turn off or turn on. Okay. The 4th span is LIPA, or low energy and low pressure application. Here we're using 10 PSI regulators instead of 15, so it requires less pressure. If you're pumping water, that means it's less energy to pressurize the system. And they spray in a pattern that's more or less straight down, but in this case, we're close to the ground, but the nozzles are every 30 inches, every 2.5 feet. And so we have more nozzles. And this is the 4th of the irrigation technologies that we're testing.
So Boyd wanted me to mention how he's doing some of the irrigation scheduling out at Vernal, as his water schedule is a bit different than what we get at Wellsville. For Wellsville, we only get water every 2 weeks. So when we do, we're trying to just get water on the ground. At Vernal, he has a bit more flexibility. And at Vernal, we have installed, similar to what Kyle has at a few of his sites, is the Zentra Cloud sensors, and the ones at Vernal are buried every 1, 2, and 3 feet. So in ZentraCloud, we can go in, see what the water content is at each level, and that's how he's doing some of his basing of how much he's going to irrigate. He's also using the irrigation scheduler app. So for the 3-way small grain forage in October of 2019, the 4-year alfalfa stand was killed out and disked up. On April 23rd, they planted the 3-way mix. May 12th, it received its first irrigation. June 2nd, it was spread with 2,4-D to help push back weeds. July 6th, it received its last irrigation, and then July 16th, it was harvested. That 3-way mix, it was 39% twin wheat, 30% Levina barley, and 30% Monaco oats, with the planting rate being 100 pounds per acre. These are the irrigations and the amount he applied at each one. He wanted me to make sure it was noted that the irrigation on May 22nd was a lot heavier than it probably needed to be. He filled up the full water profile, but that was slightly due to him learning how the lateral worked and everything. So the 3-way received about 15 inches of applied water. So the yield off of the 3-way, there was a significant interaction between the irrigation technology and the rate, as that is the main two variables we were looking at. Once again, it's another very busy graph that was simplified to the best of my abilities. The WESET at 100% rate out-yielded all the other treatments, but the LEAP at 75% and the MESA at 100% were higher of their individual technologies, but were still outperformed by the LESA at 100. The LEPAs 75% did the best, the MDI 75 did the best, and then so it's nice to see a reduction in the water there. Did not cause a big decrease in yield. If anything, they were the highest performing ones. Lisa, we did see a heavy drop in yield with the drop in irrigation, with the MDI also being the worst of the group. For the irrigation productivity, there was no interaction between the two variables with each other, but as individuals. The irrigation technology, Lisa did the best, but MESA was not too far from it statistically, still lower, but not much statistically. While with irrigation productivity, the 50% once again did the best with the amount of yield that it produced with what water it was given.